Hello everyone and welcome to Agile Tech. So in this video we're going to be looking at the Cambridge International AS and A-Level Information Technology with the course code 9626. We're looking at the first variant in paper 1, which is the theory part, and take note, it's 1 hour 45 minutes. Okay, so I'm just going to be a good student and I'll get my blue pen. Okay, and then I'll put down my name. Joe Andy, center number AN017, kind number 2024. So I'm going to school. The total mark is 70 marks. Instructions are important. Please read the instructions. I have question 1. Describe, giving an example, what is meant by the term data. So you're going to see this in chapter 1, which is what data and information. Data and information. And if we scroll down, we should be able to see that. Yes, data processing and information. So we have data and information here. Data processing and information. And here you will see that what is meant by data, data and information. Okay, so we can see that before we consider, we need to define data. Okay, to be more accurate, what data simply means is invariably it has no meaning. Okay, it has no meaning. Okay, so we can see it as they are usually known as raw data. Okay, so take note of that. And when we talk about data, raw data, it simply means that it's unprocessed. It's raw, right? When something is raw, simply means that it is what? Unprocessed. That's what it means. It means it is unprocessed. Okay, and we said examples of data, right? So what is example of data? Look at, here are some examples of set of data. So you can have P, M, you can have 1, you can have 2. Okay, but anything that has meaning is information. Do you understand? Anything that has meaning is information. So this is very important. Okay, so here you have, it has no meaning. Good. Okay, or we can say they are raw. For others, if you want to add other here, okay, so for other here you can say raw, which means unprocessed, right? They are unprocessed. Now example here could be 1. Okay, so we can just take this, some sort of data. We can have maybe 110. It doesn't mean anything, just data. So we can have 1, or you could have M. It doesn't really make any meaning, really. Okay, the B part, give an example of information and explain why your chosen example is considered to be. Give an example of information and explain why your choosing example is considered to be an information. So let's look at it. So let's look at here to see some information here. Now here you see that we can have this. They said if we're told that all these are all postal codes in India, the first set of data becomes information as it now has what? Meaning. So now we can say, okay, postal codes. Okay, so we can now say, okay, examples of this. So examples here, we can now say postal code and we can now give examples of this. So this is, for example, 110053, 110053, what again? 390 390072. Okay, so now let's give, let's say explain your choosing example is considered to be information. So the reason why it is information is because now it is now processed. Okay, so here you have it as a reason. So reason here is, it is now what? A process data. Notice I used postal code and I gave the examples of those postal code. Okay, so now it has meaning. Anything that has meaning is what? Information. So this is very, very important. Anything that has meaning is what? Is seen as what? Information. Okay, but if I just put the postal code here, it will be like, what's this? It doesn't really make sense. But now it now really makes what? Sense. Okay, so this is very important. Okay, so now they said question 2, identify 4 factors which can affect the quality of information. We'll still, this is also chapter 1, data processing and information. Now, I had to do this video because a lot of students have been on my neck because of their mock that is coming up, and they just want to have this video, and I had to just make that sacrifice to ensure that, they are good to go when it comes to their mock exam. So now let's look at this here. So let's look at those qualities. So if you scroll down, you're going to see those qualities here. Qualities of information. Look at it right here. Now, it's based on certain values, okay, and which the user places on the information that is collected. So when we talk about the qualities, how do we know what are the factors that really affects what we are looking at here? What are the factors that really affects the quality of information? So we have accuracy, right? And they said identify, command words. So I'm just going to list them. They said, but I just want to explain this. When we talk about accuracy, it simply means that the accuracy of the information will often depend on the accuracy of data collected. If the data you have collected is not accurate, then the information that will be processed will not be accurate. It's that simple. Please, you need to know that it's that simple. Okay, and that's why we usually use this method of verification and validation together to ensure that the accuracy of the information that is collected is accurate. Okay, so this is very important. So I'm just going to list it the way it is. So I have accuracy, relevance, age, we also have what we call level of detail. Okay, so we have level of details. This is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, right, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them. Question 3. Describe the computer processing involved in automatic stock control. So this is very, very important. So we'll see this in chapter 1, data processing and information. Okay, so now let's look at it for data processing and information. If I will see it in online processing, online, I think that's 1.5, online processing. Just trying to check for it for online processing. I'm going a bit fast here. Okay, so here we have for the under the data processing, we look at online processing. So for online processing, we're going to see it here. Online processing, and we'll see how well we can have electronic fund transfer and we can have automatic stock control. So yeah, looking at the question here, they said, describe the computer processing involved in automatic stock control. This is the process here. Now they said, look at it. Each record contains a different field containing that. For example, we have the barcode numbers, we have the product details, we have the price of the product, we have the weight or volume of the product, we have the number in stock, okay, and the other level. So the whole idea, okay, so because now when we're talking about the automatic stock control, we're talking about in the supermarket, right? You want to see how well what is in stock. Okay, so the barcode helps for every item that's been attached to it to know, okay, what is available, and that is why with the barcode comes the product details, the price of the product, the size of the product, to know if they are going to reorder, if they are what out of stock. So this is very important and key. Okay, so how do we look at it? Because now the question is saying describe the computer processing involved in an automatic stock control. So the first thing we have to look at is we have to look at it in two ways. How are we selling and how are we ordering? So this is very, very important. If you're going in a way, and take note of this, how many marks is this? This is 7 marks. So if you want to look at it in sales, because the whole idea is the supermarket, right? So if you're looking at it in sales, you're looking at it at, the first thing is the computer is going to read the barcode, and once it gives the barcode, it's going to search for that product of that item in the database. I want to believe everybody that is reading me right here, because I'm going to send it to you guys, right? Is now when you go to the supermarket to buy something, you get the item and you scan it with the barcode reader, right? So when you scan it to the barcode reader, what happens? It pops up the price, the item, the name of the product, and the price. Make sense? So when it pops those information up, what has simply happened behind the scene is the computer has read the barcode to identify the product, and it has searched that barcode of the product in the database. And if that product, the product or the barcode number is found, what happens? Then the number in stock is what is reduced. Do you see that now? That is why most time when they don't find when they do the barcode and they don't find the product, they have to type it manually. So once the computer scans it, the product is reduced. So that is for sales. Then for in terms of order, right? It's going to compare the number of stock in the order level. And what happens is that if the number of stock is not equal to the order level, then another set of barcode has to be returned to the start, and it goes through the whole process and goes through the whole process again. So I'm just going to put this out. Okay, so here I have for sales, please, I hope this is understood. Okay, so for sales, you have the computer reads the barcode what number. The next one is the computer, and this is something you do every day, right? Just that you don't just know what's happening behind the scene. Searches for this barcode number in the product. Okay, product, or you want to call it database, is fine. Okay, so you don't get yourself confused. The next one is that if the barcode number is found, then number in stock is what reduced. What else again? Now let's look at it in the aspect of order. In the aspect of order is that the computer is going to compare. The computer compares the number in stock, okay, to the reorder level. There's a level for it to for it for there's a level for reorder. So if it gets to that level, those items needs to be what reorder. What you would call the set value, right? The next one is if the number in stock. So let's use this. If the number in stock is not equal to the what reorder level. Okay, so what happens? Another barcode is what input. The next one is if the number in stock the number in stock is equal, okay, than the reorder level. Okay, if it's equal to the reorder level, the computer creates an order. Do you see that? The computer, and this is like two in one. The computer creates an order. Okay, then we can now see that the item is flagged to be reordered. The item, right? The item is flagged to be what? Reordered. Okay. And what again? The computer would look for the other product. I think this should be the whole process. 1, 2, 3, 4, 5, 6, 7. So that's the whole process for it. Okay. So here you can see that the computer will look up the order quantity, and then the computer will find the number for that product to be actually ordered, and so on and so forth and so on. Okay. All right. So here you can now, okay, I'll just make this as order so I can just give you everything complete. So if the item is flagged as order, the next thing is that the computer would look up. So I'll just give you everything, the whole step complete. The computer looks up the reorder quantity. Okay. And then it looks up what? The supplier number. Who is supplying it? The computer looks up the supplier number, and then the computer searches for the record of the supplier. You don't have to write this whole process. You can just crash everything together. Okay. So it searches for the record of the supplier. Okay. And then the computer orders automatically. That's why most time they'll tell you that you are currently out of stock, but will have it in stock by tomorrow at so time. And when you come to the supermarket, you have it. Hope that makes sense. Okay. Question 4. Describe the term index sequential access. Chapter 10. Database and file concept. Okay, so let's look at it. Database and file concept. We'll see it under the sequential. So let me get it, chapter 10. We'll see it somewhere around here. think see here. Yes, right here. So under the sequential access, so now they're looking for what? Index sequential access. So for the sequential access, we have sequential access, we have index sequential access. When we talk about, I want to explain both of them. When we talk about the sequential access, we're simply saying that records are stored one after the other. From the word sequential, they are stored one after the other in the order in which they are added. So it simply means that for us to be able to access that data, we have to first of all access the previous one. Now, let me give you a good example. Your magnetic tape, as simple as that. For you to be able to access the next, you have to first of all access the previous. Hope that makes sense. Okay. Now, for the index sequential, this simply means that they are not like the ones stored on the tape. They are stored on the disk to allow some form of direct access. What do I for the word index? So each record consists of maybe like a fixed length field. Okay, but the most important thing here is that there is a leftover from the use of magnetic tape where records had to be stored in order in which they are in the file. So the use of ordering facilitate what? Faster access. Do you understand? The use of ordering facilitate what? So here we can see that with an index sequential system, the records are what? In order. Hope we are learning, right? They are in order. And then we can see that this system, the index, they use that hybrid, right? So we have the sequential and then we have the index. Okay, so let's look at it. Let's summarize all this here. So let's describe this. How many marks is this? 8 marks. My God. All right, let's look at it. 8 marks, right? So the first one is it allows, for the index sequential, allows record to be accessed randomly, unlike the sequential, because now we're not adding what? The what? Index. And you see it here. We looked at it. I will say that there's leftover from the use of magnetic. So the use of ordering facilitate faster what? Access. Okay, because of the table of index is used to allow the scratch to jump to a particular place on the disk. From what index, you can ask, okay, part 4, you just jump. So it allows record to be accessed what? Randomly. Allows records to be accessed randomly. Another one is that each record is given an index. Again, it allows, I think I can put this here, it allows records to be accessed in the order they were entered. Okay, so now we can see here that even a database has several what? Indexes. That's the first thing. Because remember, I talk about database and file concept. Database have several what? Indexes. Okay, based on the information that is what? Required. Okay, so we can see that yes, each record is given an index. We talked about that, and here we can see that database may have, okay, several what? Indexes. And why is that? Based on the information required. Okay, it is also a method. Look at it. It's a method of what? Facilitating what? Faster access. So it is a method of allowing fast what? Retrieval. Okay. So data is organized into record, which consists of what? Look at it. Where is it? Consists of what? Fixed length fields. Okay, so data is organized into records, which what consist of what? Fixed length what? Fields. How many of these? 1, 2, 3, 4, 5. This 4, 6. 6. Okay. The next one is it can be searched quickly. Can be searched to what? Quickly. Okay. A bank using an expert system to help customer with financial planning. Describe the four components of an expert system. Your answer must relate to financial planning. So this is chapter 7. Okay, expert systems. So we can see that for expert system, this is the structure. We have the user interface. Okay, so we have the referential engine, which is like the search engine. We have the knowledge base, okay, which is here with the rule base, and we have the explanation system. Let me show you where it is. Sorry for using the abbreviation because obviously you can get the concept, but I'm here to show you chapter 7 so you can see it in full. Chapter 7. So you see it here. So let me just explain the whole process of how it is. So here you can see that we have the user interface, which is where the user communicates with the system. We have the explanation system. We have the inference engine. And now there's something here. This is the knowledge base. Now, this is what we call the shell, right? Now, for the knowledge base, we have the database. Of course, your knowledge base is a repository of facts, okay? And together with what? The rule base. Now, we have the explanation system, the FSC, and we have what? The knowledge base editor. So this is where we can now be able to make our edit. Now, this is really the software that allows the knowledge engineers to edit this. This is what they're editing. To edit the rules and facts within the knowledge base to bring them what? Up to date. So if there are rules that needs to be updated, the knowledge base editor does it. Okay, so I hope that makes sense. So, but now we are relating all this to what? Financial planning. Different scenarios, expert systems are used. So we're going to what? Investment. Look at it right here. We're going to all this. So if you read this, you would see what I'm going to write right now. So in the whole essence of financial planning is you're trying to plan your finances, right? Because it's quite difficult for one human expert to be able to deal with it. Okay, so the computerized expert system can assist in the process, okay, to ensure that the expert system can create a financial plan for that individual, and this includes and not limited to recommendations on how to plan it, how to manage your debt, reduce the amount of income taxes, also recommend the amount of insurance the individual has and how they can pay for retirement, etc., etc., and it goes on and on and on. Okay, so I don't just want to be explaining without writing because of time, so I will do that right here. So the first one is the user interface. All this has to be put in place. In a nutshell, all these have to be factored in. So the first one is what? A user interface. Okay, so we have the user interface where questions about, now in this case, about what? Financial what? Planning. where questions about financial planning appears on the screen. The next one is the knowledge base editor. Okay, so let's look at it. Where's it? So I want to go back to this so you can actually see it. Okay, so here you have what? The knowledge base. So we've talked about this. Now it can literally be in any order as long as you want, but I'm just going to start with user interface inference engine. So I'll go with inference engine. I'll go with inference engine. So here we have the inference engine. Let me bring this here. Okay. So the inference engine is to interrogate the knowledge base or to query the knowledge base. Interrogate or query, whichever one, the knowledge base. Okay. The next one is the rule base. Now, for the rule base, it holds what? Financial rules. Holds financial rules. The next one is I can talk about the explanation system. Explanation system. Now, for the explanation system, it describes why the conclusion describe how the conclusions were arrived. Okay. The second part describe the benefit to the bank of using an expert system. So we're still looking at chapter 7. Okay. So here we see that financial benefits of using an expert system. Now let's look at it. So still under the investment financial. So when we have this system in place, right? When we have this system in place, we can see that one benefit that we can have of using an expert system is that it saves staff's time in writing documentation. Imagine you have to write documentation for everybody, right? So when this system, because the whole idea is that these are facts or knowledge of experts that are populating the system. Okay, so it can save it saves staff time in writing documentation. Now, another one is it increased customer satisfaction. Instead of waiting in the queue, there is a system that can attend to you for any issue that you're having. So it increased customer what? Satisfaction. Okay. And again, another bit about this ESPA system to the bank is that unlike the staff, ESPA system does not need break. They are there to attend to anybody at any time. Okay, so the ESPA system, the bank ESPA system does not what need breaks. Okay, we can see that with this, errors can be reduced. Errors are reduced. How many marks is this? This is 6 marks. Errors are what? Reduced. Okay, and it is cheaper to copy an expert system than to train new staff. Because training new staff, even when you're training new staff, not all of them can be able to understand the whole process. It's going to take a while. So it's very cheap, right? So it's cheaper to copy an expert. Okay, it's cheaper to copy an expert system than train what? New staffs. I think that should be good. Okay, I need one more. Okay, we can see that now. I'm thinking of one. So okay, let's say for example, I step into the bank, I make use of the expert system. I want to ask some questions. I will find it that the expert system can give more suggestions, advice. Okay, that's good. That's good. That's good. So I'm going to write. I'm going to write it down. So expert system. Expert systems give better what? Advice than what? Human. Hope that makes sense. Gives better advice than what? Human. The C part. State 3 drawbacks to the banks of using an expert system. Now, it can lead to loss of customers. And I'll explain that. The reason why it will lead to loss of customers is not everybody wants to talk to a computer. We want to talk to a fellow human. We want to interact. Okay, see, this is happening. And most time, computers can just give a cold response that we don't even want. Okay, I submitted the money and I tried to make transaction. Well, it went through, and there's nothing we can do. Thank you. Okay, but with that human perspective, you can be able to. The human can be able to say, okay, this is what you can do. This is what you can do. This is what you can do, and there's that emotion built to it. So it can lead to loss of customers. It can lead to loss of what? Customers. Okay, and this is why I said I had to put up that scenario, because when we look at this, right, and it gives a code response, most of the time it just gives the response because that's what it's programmed to. But there are some scenarios that you really have to just apply certain intelligence, certain, not just intellectual intelligence, but your emotional intelligence. So the expert system cannot apply common sense. Okay, so that came out. So expert system, the expert systems cannot apply what? Common sense. Okay. Now the next one is one of the issues that we have with expert system is the need for constant updating of the rules. The rules can work for a while, but once there are changes, the rules needs to be what? Updated. So if those rules are not updated, the response is going to give will be based on what rules that have been put in place. Okay, so this is why it is very, very important. So the knowledge, the rule base or the knowledge base needs to be updated, whether it's the knowledge base, whether it's the rule base, because the information that is being stored there over time would need to be updated. The information that was there 20 years ago will not be sufficient to handle current issues, and that is why it needs to be updated. Okay, but my own area here is the fact that if the rules are not updated, it's still, even if the knowledge base is updated and the rules are still the same, it will not give us a correct response. So the rule base requires frequent updates. All right, question 7. An airline company uses a flight simulator to train its pilot. Describe the advantage and disadvantage of using it in this scenario. So chapter 9, modeling. This is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, right, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them. So let's look for it here. Let's scroll down to chapter 9. This 8. All right, so chapter 9 is right here, simulations. And now the question here is, so here we are seeing that the airline company is using a flight simulator to train its pilot. So here we're looking at the pilot training. And the increased number of people who travel by air increases. So numbers of pilots would need to increase too. So a new aircraft are developed. The need to train existing pilots to fly this aircraft increases. This obviously has been done as cheaply as safely as possible. It is for this reason the airline uses flight simulators and is designed to react as to a pilot instructions just like an actual aircraft. So most students think that the flight simulator games is available on PC are authentic simulators. In fact, flight simulator used by airline is a purpose-built cabin. You see it here, purpose-built cabin. Inside simulator is just as the real cabin, okay, to control the real aircraft that we would see later on. Okay, so the whole idea is that instead of driving or piloting an airplane in real life and you crash it, okay, a simulator would help you because then you have the control panel, the cockpit, which is identical to the real one, right? And they're all generated by the computer so that you can be able to see how you can lift and pilot the aircraft. So here, let's look at the advantages here. Okay, so here you have 8 marks. So let's look at the advantages here. So here you have the advantages. So advantages here. Okay, so the first one we'll look at is avoids. It avoids any what? Repair cost. Unlike, because when you're learning to ride an airplane for the first time, you're going to make mistakes. So it avoids what? Repair what? Cost. Okay, for the aircraft. We're looking at the advantage of using this for the what? Aircraft. Okay, the next one is the running maintenance cost of a flight simulator is less than the real one. Okay, so in terms of the maintenance, So here we can see that the maintenance cost of a flight simulator are less than an actual aircraft. Okay. Now, the next one is events can be simulated without waiting for them to happen in real life. So there are a lot of events that they can bring in the flight simulator. Stormy weathers, a lot of things that would help the pilot to be able to see how well to navigate. So events can be simulated. Okay, can be simulated without waiting for them to happen. Okay, in real life, which is very key. Okay, and we can also create these simulators, right, to concentrate training on specific controls. Maybe there's a particular control that you want this particular pilot to learn. We can use that to actually do that. So here we can concentrate on specific controls. Okay, so now let's look at disadvantages. I think we can put that. Another one I can talk about is the environment, because when we are using an actual plane, we're looking at pollution. So the environment can benefit from flight training in a simulator. Okay, so the environment is key. The environment benefits, okay, from flight training in a simulator. Now let's talk about disadvantages. Now, for disadvantages, what do we have? We can see that it is not realistic. Let's tell ourselves the truth. It's not realistic as the real aircraft. There's always that feel when you're with the real thing. Okay, so simulators are not as realistic. Okay, so they're not as realistic as a real aircraft. Pilot can get overconfident and may compromise safety, because I've been doing this in the simulator now, and because there is that lack of consciousness that you were just in a simulator. This is not a simulator. This is real. You can just get overconfident and you can actually compromise safety. Okay, so pilots get overconfident and may compromise safety. Okay, it is difficult to recreate fatigue of a reflight. You know, there's that fatigue of you can't create it. You know, I'm not a pilot, but I watch a lot of movies on pilot, right? Okay, I watch a lot of movies on pilot, so I can actually relate. And most time, there's this fatigue they have from driving all through for 2 or 3 trips. No simulator can create that. Let's tell ourselves the truth. No simulator can create that. So it is difficult. It can be created. I'm not saying it can, but it's difficult. With proper programming and everything, it can, but it's difficult. It's difficult to actually recreate that fatigue of a real flight, right? It's difficult. So it is difficult to recreate fatigue of what? A real flight. Okay? There's something I want to talk about. Permit me to add this. And this is something I have seen as a drawback in simulators. Pilot may freeze when faced with a real flight. Because all you've been doing is simulations, and when you're faced with the real thing, you might actually freeze. Okay, so pilot may freeze when faced with a what? Real flight. Okay? All right, let's go ahead. Compilers are linkers, a type of system software. Now, let's describe the role. Okay? So we'll see this in chapter 2. Chapter 2, hardware and software. Now, let's describe the role. Now, when we talk about the system softwares, we have compilers, we have operating systems, we have device drivers, etc., etc. Okay, so now let's look at the role of a compiler. Now, the role of a compiler, I think I can show you here, so we can both look at it together, and then we put our points. I think that's fine. Okay, and if you're not subscribed to this YouTube channel, you're doing something wrong. Literally, I'm telling you right now, you're doing something wrong. So just do your number one assignment and subscribe to this YouTube channel. Okay, and once you have done that, share this video with your friend and this YouTube channel with your friend. Okay. Okay, scroll down here. Good. So in a compiler, right? What happens in a compiler? This simply means that many consists of instruction that understands and written in binary. Okay, so when we are talking about the compiler, basically, right, it is a software that processes statements written in a high-level programming language and convert them into machine codes or codes that the computer processor understands and can execute. In other words, it translates high-level language called source code into executable files called object code. It is as simple as that. Okay, it is as simple as that. So let's put our point. So the first one is that describe the of a compiler. It's what are we saying here? Is what it translates the whole program. Okay. The whole program as what? One unit. All right. Let me look. 3 marks. Okay. What else? We can see that it creates what? An executable what? File. And how do we know that? Translate a high-level program code, high-level program called the source code into an executable file called an object code. So it translates the high level into what the computer can understand. So it can create an executable what? File. It creates an executable what? File. What else? Again, it can produce. Okay, let's talk about the fact. Let's talk about this one. It can translate the program into what? Machine code. We talked about that now. Convert them into what? Machine language or code. Translate the program into what? Machine language or code. Into machine code. All right. Streamer. So let's not stress. The roles of linkers. What does linker do? Scroll down. You see linkers. Good. The linkers has what we call a link editor. That's the first thing. Link editor. And what the link editor does here, now what the link editor does here is that it combines an object file or modules that have been created using a compiler. So what do you see here? It combines what? Object files. So here, combines object what? Files. Okay? Combines object files or modules. So whichever one you want to do. Right? Again, that have been created using what? A compiler. Okay? So it combines object files that have been created, okay, that have been created using a what? A compiler. Now, the next one is another thing we want to look at here. You can see that most programs here are written into what? Modular forms. Okay, they are written in what? In modular forms. So here we can see that that's to say with several codes of modules into a required form when combined. So another one is that it combines different modules or program code into one single executable what? Program. So you can see that a linker can link what? Modules from common libraries into what? Executable what? Files. I hope that is making sense. Okay, because here we are now seeing that it can combine different modules of object code into a single what? Executable what? Code. So it can what? Link, can link modules from a common object code into the executable code. So this is very important. So it just combines the object file into what? Into a single what? Executable what? File. Okay. And this is done using a compiler. So it combines the object code that is being created using a compiler into what? A single executable what? File or code. And where is that? It replaces addresses with what? Real addresses. That's one key thing about linkers. Okay, replaces symbolic addresses with real what? Addresses. All right. Create a pseudocode algorithm to allow a number to be entered to output a result when the number is this. And we'll see this in chapter 4, algorithms and flowcharts. Okay. Algorithms and flowcharts. Scroll down. Yes, algorithms and flowcharts. I think I have the S to be there. Okay, so now let's look at it. They said it's divided by 4. And to output a result when number is divided by 4 if it is less than 8, divided by 8 if it is between 8 and 12 inclusive, divided by 12 if it is any other number. And I've done a video on algorithms and flowchart. Please go through that video. It's right there on the A-level playlist. Please go through it. So I said write the pseudo algorithm using case and end case. So this is very, very important, using case and end case. So now the first thing we talk about is it has to have an input. So we have input number. Then we have what? The case number. So what will be the case number now? The case number is going to be what? They said what? Now, this is how we are going to do it. If it is less than what? 12. And if it's between 8 and 12, so it is less than 12. Okay? So here we have, if we have this, if it's any other number, so we can have this, if it's greater than 12, and then we have an X, and then this goes here, so the number is going to be divided with, which is divided by what? 12. Divided by what? 12. So if divided by 12, this is what we are going to have. It is any other number, okay? Which is what? 12 greater than. Here we have, if it's divided by 8, then we have it to be what? 8 and 12 inclusive. So here we have, if it's greater than 8, and then we have an X, and then we have this, okay? And then we have what? The number. Remember that we don't know the number yet. To allow a number to be entered, to output. So number divided by 8. Otherwise, we have it here, divided by 4. So this is what we do. We do this one here, and then we move to this, and then we have what? This. So you can write it any other way. So we have otherwise, okay? Otherwise this, and we have it to be what? Number divided by 4. And then it's important we end our case. So I'm going to end it here. And case. And then don't forget, we can now have our output X. Okay, so this is very, very important. Okay, all right. A company in Nairobi, Kenya, uses a database to store all its customers' details. Evaluate the use of static and dynamic parameters in a query to search the database for customers in Nairobi, Kenya. So we'll see this in chapter 10. database, and database are what? File concept. Okay. Now, when we talk about parameter query, the parameter query simply means that is it allows the user to be able to carry out some queries. It prompts the user to be able to allow it to carry out some queries, and then it's going to run, right? So here we see that they say evaluate the use of static and dynamic query. Now let's look at what they are. Let me show you what they are before we proceed with this question. See it somewhere here. Where is it? Querying the database. Okay. On a single criterion. Okay, so we have that. Creating reports on multiple criterias. Okay, I'm scrolling down to look for it. Data query, time query. This is it right here. So here we can see that, look at it right here. Static query, right? So this means that the parameter that the query uses, right, has been set to a fixed value within the query. It can only be changed by recreating the query or editing its structure. But dynamic query, this one here is dynamic, where you can be able to enter any query. Okay, enter any query and it's going to run. I hope that makes sense. So rather than creating a new query every time, that's static. Every time you want to create a query, you have to edit this whole structure. But for parameter query, you don't have to do that. For a dynamic parameter query, you don't have to do that because we have the static parameter query and then we have the dynamic parameter queries. Okay, so all these are static. Your IGCSE is static, right? But in your A levels, we're not looking at dynamic. Okay, where we can now enter all this, apply appropriate names to the query and report. Now we can see this. Okay, so the values can now change. It's not what? Static anymore. Hope that makes sense. Okay. So here they said evaluate. So when we talk about evaluate, we're talking about both positive and negative. So here I look at the positive. So the positive here is for static parameter query, it is fixed, doesn't change. Fixed, doesn't change. Okay. So another one that what we can look at it is it can save time when we read the query because we just put it straight and that's the whole process. So it saves time. It saves time when running the query. And it's less likely to have an error because there's no user input. So less likely to have what? An error. Because no what? User input required. Okay. Then for dynamic queries, let's look at dynamic queries. Dynamic parameter queries. Okay. Can be used to search for different values. Okay, and it makes it more flexible. That's another thing. Here you can see that for dynamic, it makes it more flexible. More what? Flexible. Okay, and uses a dialog box. For the user to enter the data. Okay, so you can see that you can see that for the static parameter queries, they are more user friendly. Dynamic query can save time in designing the query, as you don't need to create similar queries again. Now let's talk about drawbacks. Let's talk about drawbacks, because it's not complete if you have not talked about the drawbacks between both of them. Let's say what? Evaluate the use of static and parameter queries in a query search. So all these falls under this. I just want to talk about them. So for the static parameter query, okay, so here we can have that cannot be changed. That's a drawback. Cannot be changed. You can end up having a lot of different static queries. Having what? A lot of different static queries. Okay. Let's look at the dynamic parameter query. Okay. So for the dynamic parameter query, we can see that it requires less technicality. Okay. And also when we talk about it requires less technical knowledge of the user. Okay. And for the static, can increase storage space for the static queries. Okay. So that is very important. So here we have, I think this will just be fine. As drawback, for the static query, requires increased storage space. Okay. Question 10. Explain how each of these methods keeps data safe from unauthorized users. So this is chapter 1. We can also see some of, at least a brief explanation in chapter 5. So chapter 1, data processing. And information. Okay. So when we look at it here, when we look at it, we'll see that we have the encryption protocols, right? Which is a set of rules for setting out how the algorithm should be used to secure information. So they said what? So encryption, how do we use encryption? So we have the uses of encryption, right? There are many reasons to encrypt data, especially to stock of data and to pair rules. So the first thing we look at here is that when we talk about encryption, these data become unreadable to anybody who intercepts it. So if data is encrypted, they do not have to worry about what will happen if it's intercepted. Okay, so this is very, very important. So it can help to store confidential data about employees. Okay, so here we can see that for encryption, data is scrambled. And here you look at it here. They say what? Explain how each of these methods keep data safe from unauthorized users. So here we're looking at the first one, which is what? Encryption. Okay, so remember, if the data is encrypted, you don't have to worry about what will happen if it's being intercepted. So data is scrambled. Okay, which makes it unreadable. Not unreadable. It can be read, but not understandable. Make it not understandable. They can read it. Not understandable. Okay. To anyone who what? Intercepts it. How many marks is this? Okay. It can only be unencrypted with a key. Okay. And we can see that use of encryption is known only to what? Authorized what? Users. A firewall on a network. Remember when we talk about firewall, there are barriers between incoming and outgoing traffic, right? Now, we'll see this in chapter 5, which is e-safety. Now, the encryption is also part of it, right? Because if I'm teaching the e-safety, I also talk about all these things. Okay, so we look at it in e-safety. Now, let's look at this. Chapter 5, quickly. I will see it in prevention of, no, not prevention of something. Let me see. Um, prevention of, yes, yep, right here. Good. Keeping personal data secured. Okay, so firewall is designed to prevent unauthorized what? Access. Right? So it prevents. So here we are looking at this. So it prevents what? Unauthorized what? Access. That's what it does. Prevent unauthorized what? Access. It acts. Organization will stop that. Okay, now we tell firewall this can be accessed by unauthorized users. So firewall examine both data coming into the network to see if it's what allowable. So this is very, very important. So it acts as a barrier. It prevents certain giving access to network. Okay, so it acts as a barrier between internal and external networks. Okay, it can also create an alert in case there's incoming what anybody trying to access the network. It can what create an alert. So it creates an alert. Yeah, it prevents it from giving access. So if anyone want to gain access, it creates what? Alert. Okay. This is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, right, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them. All right. So with this, we are done with this paper. Okay, so it's been fairly easy. If you read through your textbook, you shouldn't have any issue with this, right? For this encryption, you can also see it in chapter 1. You can see it in chapter 5. Okay. um Again, database and file concept, talking about static and dynamic parameter queries. It's not really an issue because you just need to understand the concept about it. Algorithm and flowchart, I have a video on it, so please go through it to understand how the process is done. Okay. Roles of linkers for system softwares, we talked about it. Compilers. The difference between compiler and translator is that translator would convert it what line by line, while the compiler gets the whole program. Okay, so it's been fairly easy. Okay, but again, it simply means that you have to go back to your textbook, read through, go to the past papers on my YouTube channels, study with my videos on each of the chapters, and you should be good to go for your exam. Okay, thank you very much, and I would see you in the next one. Bye bye.